Welcome to Module 13, Supervised Machine Learning Classification, Decision Tree. In this model, we present the theory about decision tree as well as a case study concerning remaining useful life alert level classification. As usual, we have a glossary that defines the main concept about artificial intelligence, machine learning, unsupervised machine learning, supervised machine learning, supervised machine learning classification, and supervised machine learning regression. What we're looking at are the supervised machine learning classification. Therefore, concerning different methodologies, technologies that we have in artificial intelligence that can be applied for maintenance engineering, the most important one is machine learning, and the one that we're discussing now. So as we already defined, the machine learning concept splits some data sets in training and test data. Use the training data set that usually are 70 or 80% of the total data to test the model. So the model is adjusted, and based on the result, we use the test data to apply to this model. Then that is called the verification. So based on the error that we get in the test data and the training data, we can accept the model and then apply new data sets. If the new data sets have acceptable error, we validate the model, then we can use the model for new similar data set that we have on the very beginning. The classification model, as we already saw so far, have the same principles. And then we use, in this case, different models based and use the training data set to adjust this model and give the proper classification. After that, we use the data sets and then in the phase that we call verification phase. After that, what we're going to do is to use a new data set to validate this model. In our case, we're going to use a different remaining useful life alert level classification. And then, of course, we split our data set in training data sets and test data. Then, after that, we'll use a new data set to test if our model are proper and adjusted. Concerning supervised machine learning classification, we have different models. And what we are discussing now is the decision tree classification. In the end, we've got the different equipment criticality alert level for three different classes as a catastrophic, moderate, and low. That's represented in this graph in red color, low, orange color, moderate, and critical, represented by the blue one. The color can be adjusted as you wish. So if you want, in case of critical or catastrophic class defined as a red, is also possible. But the most important point is based on some similar equipment with different level of remaining useful life and vibration, we define which are the level that we trigger our alert of some equipment. And then in this example, we consider pumps bearing vibration. Therefore, whenever the pump, one similar pump achieve different levels of vibration, different type of alerts will come out in the maintenance screen. But to do that, we need to perform the machine learning concept. That is, use a database with different levels of vibration in RMS and remaining useful life to define which are the levels that can trigger. And then, based on it, the model will learn by itself to trigger this alert when they achieve such level. The decision tree model aims to classify the data sets based on predefined category by implementing logic rules that divide the training data set in different regions where the data are separate in different classes. So it's a very easy to understand based on a graphical representation. So since we have a data set with different with our data, we have a data set with different class, we can split the region of our universe of data that in different class. The way to take decision if one point belongs to each class is based on the decision tree. And decision tree have usual rules that define in each branch of the tree the data needs to the data belongs, and based on it, in the end we get one type of classification. The classes in the tree model are defined based on decision tree, as we already saw. And the main point here is how to build a decision tree. So the top root of the decision tree can be defined differently. So we can use this one as a top root or this one as a top root. But why we choose this specific one as a top root? So the impurity is the answer for that. So we need to check which are the top roots of the decision tree branch candidate that have the lowest impurity. In the end, the ones that have lowest impurity, the one that splits the data in the class better. So how we calculate the Gini impurity? So let's consider that we have a space with several points, as we define here in this picture. As we define here, we have these are green points, the yellow points, and blue points. So that's the space defined for all the points. So we want to calculate the probability of certain data point belongs to a K class, or this yellow, or the green, or the blue one. So the probability of a point belongs to a certain point is a certain class is defined for the number of points in this class divided for total number of points in our total space. So I need to calculate the Gini impurity for each branch, consider this probability, and there will be the probability of the class of each branch as defined. So actually, the algorithm, when we apply MATLAB or other algorithms such as R or Python, they consider the Gini impurity and build automatically the decision tree. Therefore, I will not go deeper in this detail and try to exercise how to build a decision tree, but it's very important that when we build a decision tree, we have different possibilities to have a root top this decision tree branch, and this possibility need to be compared based on this Gini impurity. So let's consider now a clear example about the decision tree that I need to build to classify equipment as low, moderate, and critical in terms of level of remaining useful life, vibration, degradation, progression, signature, and remain useful life. So in this case that we have this data set, we consider basically the vibration and the remaining useful life. And of course, we will define the class of the criticality based on the decision tree. So by using that, we will get in the conclusion that our decision tree will consider the RMS values. So here we can see the class that we classify the equipment as low, moderate, and critical. And then depends on RMS value. If lower than 4.65, we consider low. If higher than 4.5, it can be moderate or critical. So in case of lower than 5.85 is considered moderate, so actually is higher than 4.65 and lower than 5.85 is considered moderate, and higher than 5.85 is considered critical, catastrophic, let's say like that. So Based on this rule, whenever some pump bearing vibration achieve a value higher than 5.85, they will set up a alert, that is red alert, that is critical. Whenever that is below to 5.86 and higher than 4.65, they will set up an orange alarm as a moderate, for example, and when the value is lower than 4.6, they will set up a yellow alarm or no alarm. So depends how you configure it. But to get in this tree decision, that is the basis for the alarms or visual alert setup, we need to have historical data as we presented here, to use different pumps. Here we have basically three pumps in different level of vibration and remaining useful life to set up which would be the level of the alert that we need to have in a screen. So and that is the representation of the data, all these three pumps in different level of alarms. So those are the levels of remaining useful life and RMS vibration that are moderate in orange. Here the catastrophic is represented in blue, and the low critical are representing in red. So the low are the values that we have a high remaining useful life, and here you see the RMS is lower than 4.62, so they are considered low. So that's what we are defining here, 6.5. So that's what we are defining here in our tree. And then of course we can have a graphic visualization. In the end, we use this value that we define in our tree here to set up the alerts for a maintenance technician in a maintenance technician screen. Then of course we have our confusion matrix to look on how our data is classified, and the accuracy is very high. We have only one misclassification, but most of that are moderate. They are predicted moderate, but actually are low. So that was only one misclassification. That's very good model and to apply it for this data, and most of the data are true positive. They are proper classified. So the catastrophic one, that's the most important one that cannot have any misclassification, are proper classified. And the lowest one, yeah, that is the ones that's not too more important. And the moderate one, that we can also consider that is also important, because they can go from level of the moderate to catastrophic, but it need to be looking, the maintenance expert, maintenance maintenance manager need to look on it. And then of course here we have a misclassification that is something that is given an alert as a moderate, but actually is low, and that's not a big issue. The problem if it is not given an alert of catastrophic, give a real catastrophic heaven is classified as low or moderate. And then of course we can miss one of this pump vibration level, and the pump can shut down or can have a damage because of the high level of vibration, because of the wrong classification. We need to be aware that there is always a possibility to have misclassification when we apply machine learning. Unfortunately, when we look on many presentations and organizations that develop solutions that automatically give this classification, this alert, they are not show the confusion matrix and the accuracy, let's say the accuracy of their prediction. And that's very important to discussion to know, because it depends on the data. We saw here that we will have different accuracy and root error measurement. And then we can compare different methods and see which one are the best. Even some suppliers also says that they compare and they have this accuracy measurements. They compare the error of different methods, but in the end we do not see that in real practice. That's why it's important to have this type of training. That's the maintenance experts, the technician, the engineers, the leaders will be aware about the methods, what each method can do or not, and we will be aware that the method can also produce some error. So when you look to accuracy, accuracy is defined by this equation here, true positive plus true negative divided for true positive plus true negative plus false positive plus false negative. Then we got 96.30. Another index that I can use is they call recall. So recall is calculated by total true positives divided for true positive plus false negatives. So I got also 96.30%. And or precision, that is total true positive divided for true positive plus false positives. Then here I get 100%. The other graph that is possible to use is the ROC. That's the plot of this curve, and here I have 100% of area under the curve. That's a perfect relation between the true positive and false positive heights. And the way that I calculate the this true positive heights and false positive heights are present for these two equations here. So true positive heights is true positive height divided for true positive height false positive, false negative, and false positive height is false positive divided for false positive plus true negative. So in order to implement now this alert level for different pumps degradation based on a database following 3 different pumps, we apply our MATLAB software. So let's go to the MATLAB and apply and see how we do that in practice. So when we go to MATLAB, we apply this type of code. So we import the file, we create a matrix to read this file, then we define the categorical class in our matrix. This categorical class, the class that we define for different alarms alerts is critical, as critical, moderate, indifferent. It is called criticality. That's why we have criticality here. Then we split our database, this criticality file in 70 and 30%, 70% for data training, 30% for test training. Then of course we define the vector for data training, the vector matrix for data test. Then we apply here the tree model here by using the data training. And then of course we can predict the class of data training, predict the class of test, and then we are also able to calculate the error of the training data and the error of the test data. Then after that we can apply here, you see the configuration of the tree, and that is automatically. That's why I did not discussing and went through details about the Gini impurity, how to build your tree, decision tree, because in the end, if you in a real life you have too many data, you have too much to do, you use some solution, some algorithm that's considered a Gini impurity and builds up the tree for you. So, and that's what is the most important point. So, and that we've got here by defining this function. And in the end, of course, we can use this model, this decision tree model, for new data sets and validate the model. And that's what we've got from this function here. So let's see how does it works, and step by step by implement each one of to implement this code in going one by one of these commands in the MATLAB software. So here we are, we open our MATLAB, and the first point is to import the data. As we always do, we are importing now a file that we separated here for our tree model in classification. So Here we are. So the file is, as always, it will open a template. We confirm the file. Here are the templates. We can see here the templates. Now we confirm, and then we got the file in our workspace. So here we are, and then what we create now is a matrix that can read this data and as a first command. So it's very simple here. We just create. So they read the template here. You can see the criticality function here, and then the next command is to create a categorical column here. So to define that we have a class. So now we go to the next command that is split the database in training and test data. Is that this command doing here? So we have our data splitted. So yeah, I've made one small mistake here that I need to put criticality. So that's the correct command. Now they split the data, and then now I define my data training and test training. So here we are, just defining my data training. Now I will include define the data test, define my data test. So you can see here that I have in a matrix A that I have the whole data set. I have 27 lines that are all the pumps. But when I split in 70-30%, that is this commands here. So I have 90 data that is for data training and 8 for data test. It's 70-30% what I've got. So now I will include the command for the decision tree model. So now I include the command here. And what I'm doing now is to predict the class for the training data set and for the test data set. Before doing that, let's just take a look on what we have in here inside this classification tree. So we can see that we have, as I defined the data training, I have one matrix that have the 19 data that we selected for the training data sets. So and that are 19 from the first column. So they collect the first 19. You can see here the first line here is what I have, the second line here, and so on. So they get the first 19 data, and the other 8 data they use for let's say for test. Okay, so if I but we are applying now the test, and here are the categories that we have for the first 19. So we can see that we have this 19 category that we have here, we already have in here. Okay, so now I want to predict for using training data and data data to check if I have a proper if I have a, what's the result that I've got from the model. So if I want to predict the data train, I use this I will call predicted criticality one. So I use this function here, and that I got here. So if I look at this column, that's exactly what I have. If I look on the MDL epsilon here. So in the end, it's another way to predict the data training based on my function. And of course, if I want to predict the data test, I'm just using the same function. Now I change the number here to create a second function. Then here I will put test. Then I will have 8 categorical. But this 8 categorical here, I'm not able to compare what I have um, in MDL. So in MDL, actually, I have MDL2. So MDL2, yeah, exactly. I have this matrix here is exactly that I have here. So it's two ways to predict the class for the, let's say, data training test and data um, and data um, and data test. So the next command will be to calculate the error. So let's use this function here. I already tested that before. So let's call error1. Error1, yeah, let's use data training. So let's check it out, which are the error1, 0. Then I can put error2, use the same function to calculate the loss that I have in test data. So there will be also 0. So and then now what I'm going to do is to look on my function. So to look on my tree decision, and I can also input a command to display my tree decision. So as I mentioned before, by including these commands, I will have my decision tree organized by itself, and that's also, of course, considered the Gini value. So that is the decision tree that I've got automatically from the software, and they already consider the top of the decision tree here above. And based on this decision tree, they classify the data based on low, moderate, and critical, the level of vibration to set up an alarm, a visual alarm for the expert and operator. Okay, so the other possibility that we have is to look on the app, the applicative. So let's take a look on applicative and see how we can get from there. So if I want to go to the applicative, I just select here my menu as we did before, the classification learner. Then of course we'll open this template that I have to choose um, the import the data first, and then choose which data I want to apply in here. So let's waiting for open the complete template. Now it's opening, and then when it's open I can import my data. Here we are, have the options to import from my workspace that I already have imported the matrix. I don't need to import twice. So I will choose maintenance plan and templates, and then of course they automatically select the category criticality as my categorical category. And then let's move in here. I will put similar that I had before. I just split in the data here in 70 for training data and 30 for training data, 70 for training data, 30 for testing data. And then now my data will be displayed in here, and I will be able to start up with the tree model. So we can see here we have final tree, but we actually, first we need to waiting for the data be displayed here. And then of course I can select, I have RMS, and I can select RMS and RLU. So that's the graph that I've got. So this blue one is the catastrophic one that has the higher RMS and lowest remain useful life. And then consider in the decision tree, just use RMS as a parameter. So we can see that points below to 4.65 are around here are considering low. So as based on our decision tree, between 565 and 675 is considered moderate, and higher than 575, I think, is considered um, as considered critical. Is those one that have a higher vibration RMS and lowest remaining useful life here. Those are this blue here. So basically is the configuration. Then of course I will just that's are the how the data is organized actually. And now I want to classify, use the machine learning to see if the 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 machine learning process go through and the algorithm learning to classify the data. So I will use the fine tree and I run the training. So I will get here in the top the accuracy. Then I will be able to display also the confusion matrix and ROC uh, 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 graphs. And then of course the last step will be to import the functions, the function to my let's say my commands window, and then I can implement the classification for new data. So we need to wait a little bit. That's the learning process of the decision tree. The model are learning, and based on this learning process, they will classify data properly or not based on the previous data. So, and we were able to see if the data are properly classified and how is the accuracy that we achieve. So that's the general concept of classification. This is different methods that is based on decision tree, and also another method we can use depends on how is our data. But actually you see that this is one of the models that takes longer to give a results, and then that's one of the characteristics that we can also take into account when you choose one method. So here we are now, the result is coming. We're getting here soon the accuracy, and we'll see if there is some misclassified data here. So when we have boundaries like that, here there is some possible misclassification data because it's a boundary region between two classes. So of course in here we can have some misclassification. Then remember that our decision tree is based on RMS here, so we can misclassify some data. Now the result is coming. The data is classified 100% with accuracy. So here we are. We have we have these two data. We have not all this data because again, if you plot in here, we see that we have the number of the dates that we have. And we can see, so basically we have 100% of accuracy in this classification. And then we have, let's check the confusion matrix. The model brings 100% of accuracy, and that's great. We can look on confusion matrix to see if it's is the case. So the confusion matrix shows, yeah, here we do not have misclassification. So all the models are properly classified. In here you see only true positives, and if you look on the ROC curve, you see that the total area is also displayed. So here That means 100%. So just looking on, don't remember that we have here the software give display how much percent of each class we have of true positives. So we have 100%. That is the proper classification. Then, of course, in the end, we can import the model for our display and use a new data. And that's the objective in the end, that's to validate the process. So now the next step is to predict the new data set by using this prediction model. So that's what we have here. So I just copy and paste this file here. And what I need to use now is another templates that I import from here. So basically what I have are the other classification model to validate. So just demonstrating what I've done, I got from the tree model here. I have the model 2 and 3. So just click on here and I will import the model. So that is the software do. So I do the same for the model 3. And now what I want to see, if I look on this template, I do not have the criticality values here. So I want to predict this class. And the tree is the same matrix with the classification here. Okay, so I just want to test. So what I'm going to do now is to hard to have here T. I will put the name of the matrix, the template, the database that I have, the new data sets is a maintenance planning 2. That is the database here that I have with all this criticality. And then when I plot in here, I got this classification. That is similar. Let's compare with this data set what I have here. So I have CC, LL, LL. I have one missed here. You see here the 50 is I have three L's. No, that's correct. 2C, 3 L's, 3 M's, and 3C. That's 100% correct. So that's the new database with new pumps with RMS, degradation progression, signature, and remain useful life data. Then I have new classification here. And then this is that's a validation of my data sets to demonstrate that the previous model are using properly my data. So the next step now, let's just to go to the conclusion. We demonstrated the tree model, real application of the decision tree model by using MATLAB. So which are the advantages of decision tree? Is easy to implement, of course, if we have an algorithm software, and then in the end the software will display the decision tree automatically as we saw, and that's by using some algorithms such as MATLAB and or other software that will not be complicated. So the software does not require a definition of a number of neighbors or distance calculation. That's also very good advantage and less effort for data preparation. However, there are some drawbacks. A small change in the data can cause a huge change in the tree structure and classification, and usually involve higher time to train the model. So we saw that quite a simple sample of data. That took a little bit time to get the results compared with another model. So this model requires actually a higher time for simulation to get the results. So the decision tree model is also in artificial intelligence for maintenance 4.0 book. All the theory is explaining there if you want to get a test to not forget the theory. And let's move for the next model, the naive Bayes methods. And thanks for your attention. If you have some question, just ask me your question. So let's move to the next model.